Okay, so let's suppose the directions was this. It'd be the same directions as on that worksheet y'all turned in last class period. So basically say something like this. Determine the values, and there could be more than one, the values of x for which the rational expression is undefined. So before we can talk about the domain, let's talk about what we mean from that previous worksheet. So determine the values of x for which the rational expression is undefined. So let's suppose I had this rational expression, x minus 5 divided by 2x minus 9. And that was that back part of that worksheet. So remember, a rational expression is undefined when what occurs? When the denominator is 0, because you can never divide by 0. It doesn't matter what the numerator is. The numerator can be any real number, even 0. It's the denominator that cannot be 0. So what you need to do is ask yourself, well, where is this denominator? In this case, the expression is 2x minus 9. Where is that equal to 0? So all you do is you take the denominator and set it equal to 0. And notice, what kind of equation did I just write? A linear. So I solve this linear equation. So I'm going to add 9 to both sides. So I get 2x equal 9. And so what's my x value? 9 over 2. Now what I found was this. I found that the value of x that makes this expression, this rational expression, undefined is when x is what number? No, not 0. When x is what number? 9 over 2. Okay? That's the value of x that makes this rational expression undefined. Not 0, because when you say 0, you're saying x is 0. Well, look at this. What's 2 times 0? What's 0 minus 9? Well, my denominator is negative 9. That's not 0. Okay? So 9 halves is what makes the 0. And you can check, what's 2 times 9 halves? What's 2 times 9 over 2? What's 2 times 9 over 2? Guys. 9. And what's 9 minus 9? 0. Okay. So what you put in the blank, though, was this. You said, in the answer, you'd said x equal 9 halves, which is fine. X equal 9 halves, that's a true statement. 9 halves makes this, 9 halves is the value of x that makes this rational expression undefined. Okay? Number 2. We're going to do one more, and then we're going to talk about the domain. All right, number 2, suppose I had this. Suppose I had x plus 2 divided by 5x squared minus 3x. All right, I want to find out what values of x makes this rational expression undefined. Well, when is a rational expression undefined? When the denominator is 0. Well, what is this denominator here? 5x squared minus 3x. So I got to see, when is that equal to 0? Well, what kind of equation did I just write? That's not linear. That's quadratic. That's a quadratic equation. And how do you solve this particular quadratic equation? You're going to factor. Remember, on test number 3, if you look at your study guide, one of them was to solve a quadratic equation by factoring. So notice I wrote a quadratic equation. You need to know how to solve this by factoring. And how do you factor the left-hand side? GCF is x, so you factor out an x. So you get x times what? Minus 3. And then once you factored, remember you're solving a quadratic equation, so the first step is to factor. Once you factor, what's that next property that you used? Zero factor property. What are your 2 factors that you see here? X, and the other one is 5x minus 3. So I said each one equal to 0. So I said 5x, I said x equals 0, and I said 5x minus 3 equals 0. So notice I went from a quadratic equation to two, what kind of equations are these? Linear. Here, this linear equation, the variable x is already by itself. So I found one of the values that makes this denominator 0. What's one of them? 0. The other one, I'm going to add 3 to both sides. So I get 5x equals 3. So what's the other value of x? 3 over 5. So those are the two values of x that makes this rational expression undefined. So the question was, or the directions was, determine the values of x for which the rational expression is undefined. So when is this rational expression undefined? When x equals two things. What are they? 0 and what else? 3/5. So that's what you had to do on that back page of that worksheet. That's what you had to do here. Okay? All right, let's talk about the domain. All right. So now that we reviewed the first part, let's talk about the domain. All right, let's find the domain of each rational expression and state the domain So write the domain, or find the domain of each rational expression, and then you want to state the domain in set notation. So if you understand what we just did now, then this should not be an issue. Okay, number one, I'm going to give you a rational expression. So let's suppose we have this rational expression. 3 divided by 5x. So I want to find the domain. Now, what I mean by that is this. Okay, so I'm going to go back to that worksheet that we were referring to a while ago. Except in this case, I'm going to look at the first page, the front page. So here's the front page. Remember this right here? So I gave you rational expressions, and I asked you to evaluate those. So let's do the first one. So I asked you, I said, what is the value of this rational expression when x was what number? 3. I just chose 3. I could have said when x was 2.7. I could have said when x was negative 100.8. I could have done any of those. I just chose which one? 3. Question is this, though. What number could I have not chosen and told you to use? Huh? No, 4 works. What's 4 minus 7? Negative 3. What's 4 plus 4? 8. I get a number back, just like I did this. I couldn't use negative 4, thank you, because negative 4 makes the denominator 0. So remember, the domain is the set of x values. Remember that? Okay, so if this was my expression, I'm asking what's the domain, I want to know what are the values of x I can use. What you may want to do first is find out what can't you use. So what value of x couldn't I have used here? Negative 4, because negative 4 makes the denominator 0. So when I go back over here, this one here, I want to find the domain. I want to find out what values of x can I use and get a value of this expression. For instance, if x is 6, will I get a number? Yeah, I'll get 3 over 30, right? If x is negative 2, will I get a number? Yes, I'll get 3 divided by negative 10. But what can't I use? 0. Because remember, first thing you want to do is find out where's this thing undefined, just like we did here. Just like we did this. Find out where is this undefined. So this expression is undefined. when 5x equals what? 0, which means x is equal to what? 0. Does rest undefined. So that means that's the only restriction. This is the only restriction. That's the only restriction. So I can use any number for x except which number? 0. So in words, the domain would be this. In words, the domain would be all real numbers except x equal what? 0. That would be the domain. All real numbers except x equals 0. That's what you would say in words. I can use any other number for x. Remember when we graphed those lines, I used the t-table? And basically when graphing those lines, I could use any value for x, any value, and I get a value for y back. That's the idea. Except this time it's not a line. You don't know what the graph of this looks like yet. You're going to graph these next semester. Now let's talk about how to write this in set notation though. So in set notation, here's how you're going to write this. Now listen carefully how it's going to look. So the domain will equal, you're going to say brace to mean set, the set of x's, such that, see this vertical segment right here, that means such that x is a real number, and you tell me what x cannot be now. What can't x be? 0. So that's how you would write this in set notation. So what I just wrote was this. The set of x's such that x is what kind of number? A real number, except what can't x be? 0. So that means all real numbers except what? 0. Okay? Now in my math lab, when they ask you for the domain, they're gonna have all this written out, except they're gonna have a blank here, and they're gonna have a blank, and in the blank you just say x cannot equal 0. That's what you would put in my math lab. So my math lab's gonna have all this written, and it'll have a blank here, and you just put this in the blank. Now in the worksheet you're gonna get, you have to write all that in the worksheet. Okay, number 2, what if I had this rational expression? Negative 8x divided by x plus 8. You want to find the domain. Well, think about that previous worksheet. It's the same idea. You want to find out what values of x can you substitute into this expression. Well, first of all, find out where's it undefined.
Negative 8.
Y'all agree it's negative 8? Because you take the denominator, x plus 8, and you find out where that's equal to 0. So what kind of equation did I just write? Linear. So what's x equal to? Negative 8? So that's your restriction right here. So that's where, in other words, that's where my rational expression is undefined. So in other words, I can use any real number except what? Negative 8. So your domain then would be the set of x's such that, and what else do I write? What do I write? X is a real number, and x what? Cannot equal negative 8. That's what you write. Okay, number 3. Number 3, suppose I was dealing with this rational expression, 5 divided by 3x squared. plus 5x minus 2. So 5 divided by 3x squared plus 5x minus 2. Now that one's a little bit more difficult, more challenging, because in the previous two that we did, when I said the denominator is equal to 0, what kind of equations did I write? Linear. Here, my denominator is not a linear expression. What kind of denominator do I have? Quadratic. So again, if I want to find the domain, I need to first of all determine where's this rational expression undefined. Well, a rational expression is undefined when the denominator is what? When the denominator equals what? 0. Doesn't matter what the numerator is. It's the denominator. You can't have the denominator be 0. So what kind of equation is this? Quadratic. All right, now remember on test 3, you are going to have to solve a quadratic equation by factoring. So you could see this on test 3. So how do I solve this by factoring?
First you factor it.
Okay, first you factor it. The GCF is 1 though, right?
Yep.
All right, so then you do your 2 factors. So 3x. I think the 2 is going to be in the second parentheses. The 1's in the first. The last sign's negative. That means these signs in here are different. And I think the first parentheses has the negative symbol. And the second one's the plus symbol. All right, remember, you always check yourself before you go on. What's the outer? 6x. What's the inner?
-1.
And when I don't know, do I get that 5x?
Yeah.
Yeah, and also check your last. What's the -1 times 2? -2. All right, so in your test, you are going to have to solve a quadratic equation by factoring, so make sure you remember how to do that. Okay, now once you factor, what property do I use next? The 0 factor property. So I said each factor equal to 0. So I get 3x minus 1 equals 0, x plus 2 equals 0. So notice I went from a quadratic equation to 2 linear equations. So you add 1 to both sides, so you get 3x equal 1. So what's one value of x for which this rational expression is undefined? 1/3. And over here, that one's an easy one. What's the other value? -2. So again, what you found were your restrictions. So in other words, I can use any value for x, any real number, except which 2? 1/3 and -2. Now, the domain is, if they ask you to write in set notation, do you have to use set notation? So you'd say the domain would be the set of x's such that x is a real number, and then remember, my math lab is going to have those words, and it was to have a blank. What's going to go in that blank in my math lab?
1/3.
X cannot equal, and it will have x cannot equal already for you. It will say x cannot equal, and what would you put in that cannot equal? 1/3, comma, and what's the other one? -2. So make sure you put that comma there. So that's your domain. So meaning that it's any real number except which 2 can I not use? 1/3 and -2. All right, let's do one more. So this is number 4. We have 3x minus 10 divided by 4x squared minus 9. All right. So I want to find the domain of this rational expression. To find the domain, what is it I've got to ask myself first? Where is this rational expression undefined? Where is the denominator equal to 0? So I get 4x squared minus 9 equals 0. Now remember, what kind of equation did I just write? Quadratic. Okay, now remember, on the test, it's gonna say solve this quadratic equation by factoring. Okay, so if it says factoring, you got to use factoring. You got to follow directions. So how do you solve this equation by factoring? Difference of two squares. So 2x minus 3, 2x plus 3. And so then I said each factor equal to 0 using the zero factor property. So I get 2x minus 3 equals 0. 2x plus 3 equals 0. So notice I went from a quadratic equation to two linear equations. So if 2x minus 3 equals 0, then that means 2x equals what? 3. So therefore x equals what? 3 over 2?
Yep.
Over here, 2x equals a negative 3. So x equals a negative 3 halves. So I found the two values of x that makes the denominator 0. So remember, those are your restrictions. Once you find those, then you know your domain. The domain, I can use any number for x except which two numbers? 3 halves and negative 3 halves. So you say the domain would be the set of x's such that x is a real number and x cannot equal what two numbers? 3 halves, negative 3 halves. All right. Okay, now, remember we solved this quadratic equation by factoring? Now remember, the direction says solve by factoring, you use factoring. But I just want to remind you, and we talked about this in a previous lesson, you could have also solved this quadratic equation this way, just to remind you. Notice there's only two terms here. There's the x squared term and the constant. So the x term is missing. Whenever the x term is missing, remember you can get x squared by itself. So you'd say 4x squared equal what number? 9. Then divide both sides by, how do you get x squared by itself? Divide both sides by 4. And these 4's divide out, so you get x squared equal 9/4. And then you get x by itself using what property? Come on, you had this before. Using the square root property. So you take the square root of both sides. Remember that plus or minus? So the square and the square root undo each other. So x equals plus or minus what? 3 halves? Okay. But this is not factoring. This is factoring. Y'all don't remember this?
You did it last class.
No, I don't know when we did this. But the reason I'm saying this is because this. So, what? Okay, so we're done with this part. So that's all I need to do with this.